Hello everyone, in this video I will be revising some of the steps involved in doing calculations for titration questions. Before we start, I just want to quickly recap some useful formulas. The first two I think everyone knows already, but I'm just going to write it again. So the two formulas that allow you to determine number of mole of substances. The first one involves mass, number of mole and molar mass, and the second one is number of mole, concentration, and volume. Obviously, the concentration that is in this formula is molar concentration or concentration in mole per liter, and you are not going to be able to use this triangle if the concentration is something else. Which means that you also need to recognize the different concentration units, which if you look at the chromatography PowerPoint, I think that's the one that has a recap on all the concentration units. So we're talking about things like percentage mass per volume, which is just another way of saying grams per 100 ml. So grams per 100 ml. Or you can have percentage volume per volume, which just means that the volume per 100 ml. You can also have ppm, which is parts per million, ppb, and things like that. Or sometimes you just have simple units such as grams per liter. So different concentration units can come up in titration questions beside molar concentration. The last formula that I want to remind you that can be very useful in some circumstances, and I think students tend to forget that this is a thing, which is the formula for density. So density is just a ratio between mass and volume. So if you want a triangle, then you can use this one. So density is just mass over volume. The unit for density normally is in grams per mil or kilograms per liter. So if we're using grams per mil, the unit for volume will be in milliliters and the unit for mass will be in grams. So for example, the density of water is 1.0 grams per mil, but other liquid may have different densities, so you can't always assume that everything has a density of 1. So that's just some formulas for you there. I'm going to go through two questions. Now, whenever you see a titration question, it really depends on how complicated the question is. But especially if you're starting or you're not very confident, then I do always recommend that you summarize the question and maybe create a flowchart as you go along. And that really allows you to keep track of all the numbers and the information that's given to you, especially with some of the questions that you're going to see next week when we do the worksheet. Some of them can get quite full on. So I'm going to try to summarize the question here. First piece of information, tartaric acid is an acid that occurs naturally in grapes and other fruits. Okay, the structure of tartaric acid is shown, and you have a skeletal diagram for tartaric acid here. Now, the first thing that you need to notice is that there are two carboxyl groups present in this molecule. So this molecule is a diacid, and it also contains two hydroxyl groups, but it's the carboxyl that is of interest here, because this two carboxyl group means that this is a diprotic acid, so it can donate two hydrogen ions, which is going to affect the mole ratio of the equations a little bit later. So I should say 2H plus, so that's the acid. So already second sentence, and I've gained some really useful information. To determine the concentration of a solution of tartaric acid. So the end goal here, and I think it's very important when you do any question, especially analytical chemistry, is you need to know what is the ultimate purpose of a particular analysis. In the case of titration, you always want to determine the amount or the concentration of something. So in this case, the end goal is to find the concentration of tartaric acid. So my final answer has to be in the form of concentration of tartaric acid is blah, blah, blah. To determine the concentration of a solution of tartaric acid, 25 ml of the solution is titrated against a 0.5 molar sodium hydroxide solution. So if they use this language, if they say titrated against, what it often means is that the conical flask is going to contain the acid. So the 25 ml is going to go in here. So that's the volume of the acid. So V is 25, and this is your acid. And it is titrated against whatever is in the burette. So the burette, I'm going to draw it on top. the burette is going to contain sodium hydroxide, which has a concentration of 0.50 molar. The average titer was 25.76 mil. So if the average titer is 25.76, then that will be the solution that comes out of the burette, which also means that it is the volume of sodium hydroxide. So that's the volume of sodium hydroxide. And then the question asks you to determine the molar concentration of the acid. Okay, so this is a fairly simple question. The concentration is to be given in mole per liter, so you don't have to do any fancy conversion at the end. All right, so basically we just need to find the concentration down here. All right, so the first, I've summarized the question, and always start with the section that you know the most, or the section that you have the most information of, which is this one. So I have the concentration and the volume of sodium hydroxide. What I'm going to do is, first of all, I'm going to convert the volume to liter. And then from here, my first step, I think, is going to be to determine the number of mole of sodium hydroxide. So step one is to find N of NaOH, which is going to be concentration times volume. Now, obviously, you're not going to do any of this by hand. I'm just trying to find my calculator. All right. So 0.5 times 0.02576 is 0.01288, and the unit is mole. So that's the number of moles of sodium hydroxide. So you've used this many mole of sodium hydroxide in this particular question, and the next step here is now you're going to have to jump or take the bridge, make the connection between the sodium hydroxide or the base to the acid solution, and this is where an equation is going to come in. Now, it's not correct to assume that every single question is going to have a 1-to-1 ratio between the acid and the base. That's just too good to be true and probably not going to happen in year 12. So in order to know what is the acid and base ratio here, I think I'm just going to quickly revise what an acid-base reaction is. So an acid-base reaction is one that involves a transfer of protons from acid to the base. Now with year 12 chemistry, and because this is under organic chemistry, you need to pay attention to organic acids, which essentially are the carboxyl groups. Each group is a weak monoprotic acid. In the example of tartaric acid, because there are two carboxyl groups, the taric acid as a whole is a diprotic acid. And you also have the organic base group. So an amino group is a weak base, and each amino group can accept one proton or one hydrogen ion. So if you have multiple amino groups in a base, then that base potentially can accept many hydrogen ions. You need to look at the structure of the acid and or the base to determine the mole ratio in the equation. So in this case, I have tartaric acid, which is a diprotic acid, which means that because it is a diprotic acid, I'm going to need 2 NaOH to fully accept the hydrogen from the tartaric acid. So one H is going to go to, say, this NaOH, and the other H is going to go to this NaOH. And it's going to produce 2 H2O, one from each combination. And now when you write the salt, it's up to you how you want to write it. You can write 2Na plus because it's probably going to be soluble in water. And then you have this organic compound left. So I'm just going to do the carbon chain first. 1, 2, 3, 4. So let's see, 1, 2, 3, 4. So you have the O here. Still, the OH is intact. The OH is intact, and I have a double bond O here. So there is an O minus on one side and an O minus on another side. Remember that if you've taken away a H plus, whatever's left has to have a negative charge so that the overall molecule has a neutral charge. So the ratio, the mole ratio, if you will, between an acid and the base in this case is actually a 1-to-2 ratio. For one acid, because the acid is diprotic, you actually need 2 of the sodium hydroxide molecules. All right, so if I go back to my question, now that I have the number of moles of sodium hydroxide, I need to use it to determine the number of mole of the acid. And this is where the mole ratio comes in. I'm just going to rewrite the mole ratio from the equation that I wrote earlier. I don't have enough room in here, that's why I don't want to write it again. So my ratio was acid to base is a 1 to 2 ratio. So it's up to you. I mean, this is where you can use the unknown over given. So you can create a ratio in the form of unknown over given. You just need to know what your unknown is. You want to find the number of mole of the acid. So that's your unknown. So we go unknown. And the given, well, it's not technically given. You just worked it out yourself. But you know, or unknown of unknown, if you will. The amount that you already know the number of moles of sodium hydroxide, so that's your given. So the unknown of a given is going to be the number of mole of the acid over the number of mole of sodium hydroxide, which is a 1 to 2 ratio. So the number of mole of the acid is going to be half of the number of mole of sodium hydroxide, because you need twice the amount of NaOH to react with the acid. So I don't have enough space here, so I'm just going to do the math in the calculator. You just need to halve 1288, which I guess you should be able to do by hand. But it's kind of late and my brain no longer functions, so I'm going to do it in the calculator. I mean, I should be ashamed. But anyway, so that's the number of mole of the acid. And that's it. Once you've had the number of mole of the acid, you should be able to work out the concentration. Once again, the volume of the acid has to be converted to liter. So step 3, the concentration of the acid, it's going to be number of mole over volume. So maybe I should have enough space just here. So that's 0.00644 over 0.025. Okay. So final answer, let's see, we need 2 sig fig because that's the concentration of sodium hydroxide given. So 0.26 mole per liter is my final answer. Okay, so that's example 1, classic acid-base reaction, titration. Obviously, the question can be more complicated if there is a dilution and a sampling in the mix, but we don't have to do any of that just yet. So I just want to give you one more question. So example 2, so let's go through it together. The blood alcohol ethanol, so this is ethanol level. The blood alcohol level can be determined by titrating a sample of blood plasma. So once again, now level is a little bit vague, but I think we're after concentration of ethanol here. The concentration of ethanol normally is measured in percentage mass by mass, which is, so when we say 0.05 or 0.5, that's actually concentration percentage mass by mass, not mole per liter. So it can be determined by titrating a sample of blood plasma with an acidic potassium dichromate solution, resulting in the production of chromium ions and ethanoic acid. So this really depends, like whether or not you understood that sentence depends on how much you remember the redox reaction of an alcohol. So ethanol can undergo oxidation, and it can undergo an oxidation reaction with potassium dichromate, which is going to be the oxidizing agent. And these are the two products of this redox reaction. The reaction can be monitored because the dichromate ion is orange in solution and the chromium ion is green. So this is a redox titration that is self-indicating. When the reaction is finished, it actually shows you the color change because the reactant and the product have 2 different colors. So this is a redox titration. Okay, if 31.05 ml of 0.06, so what I'm going to do is I'm just going to draw the burette out because some people find it easier if they can visualize it. So potassium dichromate, K2Cl2O7, the volume is given to be 31.05 ml, and the concentration is 0.0600 mole per liter. Okay, it's required to titrate 30 grams of blood plasma. Now, blood plasma is not pure alcohol, I hope. So 30 grams is actually not the mass of the alcohol here. It's just the total amount of the plasma. It's 30 grams. you need to determine, and once again, this question is already a lot more interesting than the previous question, because you actually need to find the concentration of ethanol in percentage mass by mass. So you need to find C of ethanol in percentage mass by mass. Okay. In order to determine the concentration of ethanol in percentage mass by mass, I think it's probably a good idea to start with this, and you need to know what percentage mass by mass actually means. That's the same as mass of ethanol in 100 grams of plasma, or you just need to find the percentage by mass of ethanol in 30 grams of the plasma. So if I can determine the mass of ethanol, I can determine the percentage mass by mass concentration. So in order to get to here, what I need to do is I need to find the mass of ethanol in this plasma sample. Okay, so that's the intermediate unknown, if you will. Now there is a titration going on here, so I'm going to need to use the fact that there is a titration. Since there is nothing I can do at this point, as of yet, my first step is going to be to find the number of mole of potassium dichromate, just because I can, and you know, if you don't know what else to do, there's a t-shirt that I've seen which I'm always regretting not buying. It's like when in doubt, find the mole. Just so good. I think it was in a museum, like a science museum. So you have to convert the volume to liter. So 0.0, okay, 0.03105 times 0.06. So 0.03105. So the number of mole potassium dichromate is 0.001863. So this is the number of mole potassium dichromate. Red, what do we do now? Now, the issue here is you need to be able to go from potassium dichromate to ethanol. So once again, you need to be able to make that link between potassium dichromate and ethanol. And if you go back to example 1, the link between the two substances is the mole ratio. So unless you have the mole ratio, you can't make that link. Now, if you want to have the mole ratio, you need to have the reaction, or the equation to the reaction. So the question here is, what is the equation for this redox reaction? Now, you're gonna need to be able to use cohes to fully balance the half equations and then add the half equations together to get the full equation. And I'm sorry, but there's just no other way around that. Okay, so if you go back to the question, they actually tells you enough information to be able to write the half equations. So C2H5OH is going to turn into ethanoic acid, whereas, what was the other one? Potassium dichromate, so mainly the dichromate ions, is going to turn into chromium. So I'm going to have to do, for step 2, I'm going to have to start by actually writing out the equations. So C2H5OH. Now I do recommend that when you write half equation that you use the molecular formula. So instead of writing C2H5OH, I would write C2H6O, just because it makes it a lot easier to not forget like a hydrogen or an oxygen when you balance everything. C2H4O2 is just the combined the molecular formula of ethanoic acid. So ethanoic acid is CH3COOH. So I'm just gonna write it as C2H4O2. So cohes again, carbon, 2 carbon on either side, so carbon is balanced. In order to balance oxygen, I need to add a water. There are 8 hydrogen on the reactant side, so I need 4H on this, and then 4 electrons. Okay, so that's the oxidation half equation. The reduction half equation is Cr2, that's supposed to say Cr2O72 minus going to Cr3 plus, so key element. I need 7 water, 14 H plus, and I think I'm going to go with 6 electrons actually, so that's 12 plus 6. All right. Oh, don't you just love it when one is not a multiple of the other? So 3 times the oxidation and 2 times the reduction is going to give me the overall equation. Now this question doesn't actually ask for the overall equation, so if I do this question, I wouldn't even bother writing the whole thing out because I don't care. All I care about is the mole ratio between the dichromate and the ethanol. So I'm just going to write this and dot dot dot, and this is enough because all I need is these coefficients. If you're terrified and you think that your balancing is not correct, you can write the whole thing out, but I don't even think I have enough room here. Okay, so we have that, which means that the number of mole, or the mole ratio between these two is a 3:2 ratio. Okay, don't know why I have that random line there. I think this may be a bit better. So we already have the number of mole of potassium dichromate. Now, if you look at the formula of this ionic compound, there is one dichromate per potassium dichromate. So the number of mole of potassium dichromate is going to equal the number of mole of dichromate ions. So you don't have to double or triple anything. It's so easy to make this question so much harder though. So I'm going to go from here in order to find the number of mole of alcohol. So unknown. The unknown in this case is going to be ethanol. So the number of mole of, let's write it as C2H6 H5OH again, just to make it a little bit easier to understand. And that over the number of mole of dichromate. So the ratio is 3:2. According to the equation. It's a 3:2 mole ratio, which means that the number of mole of ethanol, it's going to be 3/2 times the number of mole of dichromate ions, and that is 3/2 times this number, so 0.001863. Okay, so let's do that. Why is the number so long? How am I going to write this in? I'm just going to write the answer in here because I think I need a little bit more space. 0.002795. So this is the number of mole ethanol. You're almost done now. You just need to find the mass of ethanol, and then you can find the percentage mass by mass. So mass of ethanol is just number of mole times molar mass. The molar mass of ethanol is 46, but you can work it out yourself. So you're going to have 0.128547. This is already a good sign that it is smaller than, I think the other one was 30 grams. I mean, if you get 40 grams of ethanol in 30 grams of blood plasma, you've done something wrong. So the last thing I'm going to do is to find the percentage mass by mass. I just need to find the percentage of this mass in 30 grams. So percentage mass by mass. So 0.128547 over 30, and then I'm times it by 100 to get the percentage. All right, we're looking at 3 significant figures. So 0.428%. So that is my final answer, percentage mass by mass of ethanol in the blood plasma sample. So that's all for the 2 examples. We will do a lot more practice next week, and the questions will get a lot harder, but at least let's just start with being able to do example 1 and 2 first. Thank you.